high sample rates and large record lengths, modern oscilloscopes can produce multiple gigabytes of waveform data in just a fraction of a second. In many applications, getting this data off the instrument quickly is very important. While Ethernet has a very large speed advantage over older interfaces like GPIB, the overhead of SCPI commands and the VXC11 protocol has prevented instruments from being able to fully realize Ethernet's full potential. To take advantage of the speed of Ethernet, we developed Tektronix High-Speed Interface, or TekHSI. TekHSI is based on gRPC and protocol buffers to quickly and efficiently serialize waveform data produced by the oscilloscope and transmit it over Ethernet. The 7 Series DPO features a TekHSI server built in, allowing client applications to connect and receive waveform data from the oscilloscope. The data is automatically pushed to connected clients immediately after it is acquired, ensuring prompt data transfer with no waveform missed, no matter how fast the acquisition rate. Multiple channels worth of data can be moved all at once, ensuring that all waveforms are from the same acquisition. With TekHSI and the 10 gigabit per second Ethernet interface on the 7 Series DPO, waveform data can be moved off the scope at rates of up to 1 gigabyte per second. To demonstrate this capability, I have written a Python script that connects to the TekHSI server as a remote client and simply receives waveform data after each new acquisition is completed, and then writes it to the disk. To maximize throughput and keep up with the stream of incoming waveforms, the script receives the waveform data on one thread and writes it to disk using multiple writer threads. By making use of a Tektronix-supplied library that includes the Tektronix.wfm file format, this script writes the data to disk in the native TeK file format. This library can be included in your own Python scripts so that you can save and recall data in .wfm file format or in CSV.
Also included with the TekHSI package, the TM data types library can convert .wfm files to CSV files or vice versa, with only a few lines of code.
First, I'm going to enable the TekHSI server on the instrument by navigating to the Utility I/O configuration menu. Inside the high-speed interface panel, I'll choose SFP Plus from the network connection dropdown so that I can utilize the port to achieve a much faster data rate. The SFP Plus port is capable of up to 10 gigabit per second data rates and can be configured in multiple ways. Fiber optic SFP Plus modules can be used for longer reaches or when electrical isolation between the instrument and the system controller is required. For many existing installations, SFP Plus to RJ45 modules can be used to run 10 gigabit over existing Cat5e or higher twisted pair cables. For shorter reaches under 5 meters, inexpensive direct attach cables can be used to directly connect to other network equipment with SFP Plus ports. Finally, I will enable the TekHSI server by simply turning it on. With the TekHSI server now enabled, it can accept connections from remote clients and will push data to any connected clients whenever new data is available, without having to query the instrument. I'm going to run my Python script, which will wait for new waveform data coming from the 7 Series DPO, and will simply save the file to a specific drive location. Pressing the single button on the 7 Series DPO will acquire an acquisition. You can see the file quickly show up on the computer's file browser. Pressing the single button again shows another file being saved, indicating no need to query the oscilloscope for the next waveform file. The oscilloscope pushed the data to every connected client via the TekHSI server. I don't want to keep pressing single on the oscilloscope. Instead, I want the flow of data to be real-time as soon as a new waveform is available. So I'm going to press the Run button to start continuous acquisition of waveforms and send each new waveform to the client PC for archiving, which this new transfer protocol can do. So let's go ahead and press Run. Wow, look at how quickly this file browser is filling up with new waveform files. To show that we have complete waveforms, I can open one of the waveform files in TekScope PC, our off-scope version of the oscilloscope application. You can see the sine wave from the instrument here. Take advantage of this free TekHSI capability along with a 10 gigabit SFP Plus Ethernet port to move data faster than ever before.